Okay, we've been given this relatively tricky probability question where we've been given two events such that the union of the two events equals 0.85 and the probability of the initial event happening is 0.25, and we have to find the probability of the other event happening. Now, what we can start by saying with regards to independent events is that if two events are independent, it means that the probability of one event happening is equal to the probability of that event happening given that the other event happens. Now, this A given B probability can be also determined using this equation. The probability of A intersect B divided by the probability of B. Okay, now once we have this, we can just lose the middle part and say that the probability of A is equal to the probability of A intersect B over the probability of B because they're independent events. Now, the other equation which links the probability of A, the probability of B, the intersect as well as the union is this formula. Forgive my handwriting. Probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B. Cool. Now what we're going to be able to find is if we rearrange this initial equation at the top, we can slot it in here and solve for this A intersect B. And that's going to be the first step. So what we're going to do first is we can rearrange this top one into the probability of B is equal to the probability of A intersect B divided by the probability of A. And what we're going to do is we're going to substitute this relationship for this probability here. So what we then do is we're going to say, so this formula will then become the probability of A union B is equal to the probability of A, which by the way we already know, plus, let me just, plus this, which we've just deduced, the probability of A minus the probability of A intersect B. Okay, now that we've got this is something where we only have one unknown, which is this probability of A intersect B. So if we only have one unknown, we can solve for it. What I'm going to initially do is I'm going to move this probability of A across to the other side, and that will leave us with the probability of A union B minus the probability of A is equal to, what I can also do here is I can factorize by A intersect B. So I can write now the factors, we have to times this one by 1 over the probability of A. And then we just have to take 1. Cool. Now what we can do now is we can substitute in some of the numbers that we know. So A union B is 0.85. Minus probability of A, 0.25. And this is equal to the probability of A intersect B, which we don't know. Multiplied by 1 over the probability of A, which is 1 over 0.25, which is equal to 4, minus 1, or 3. So what we can then go, or what we can then do, is we can go 0.85 minus 0.25 is 0.6. And that's equal to 3 times the probability of A intersect B. So then we can say the probability of A intersect B is equal to 0.2. Cool. So now we have the probability of A intersect B, we have the probability of A, and we have the probability of A union B. So we can use this formula here rearranged so we can have it, we can identify what the probability of B is. So what we can do is we can go the probability of B is going to be equal to the probability of A union B minus the probability of A plus the probability of A intersect B. Now, what I've done there is I've just rearranged this equation here. So once we've done that, we can go, okay, well the probability of A union B is 0.85, they give us that, minus the probability of A, which they also give us, 0.25, or a quarter. Then we're going to add back the probability of A intersect B, which is 0.2. And so that all up, therefore the probability of B is 0.85 minus 0.25 is 0.6, plus 0.2 is 0.8. So we can say therefore probability of B equals 0.8. Now that's one of the more tricky independent events that you're likely to see. So if you can master that method, I'm pretty sure you'd be able to handle any probability question.